got emails from them for my kids.
Okay. So last time we looked at a normal distribution. These three percentages are not random percentages. Like, I want you to kind of know those. So 68% of the values in a normal distribution will be within 1 standard deviation. 95 will be within 2. And then 99.7, some textbooks call that almost all, because I mean it is almost all, right? If you had a 99.7% chance of something, it'd be pretty certain, right? Of being within 3 standard deviations, okay? So honestly, my picture's a little exaggerated. Like, look how tiny amount of sliver of area is kind of outside of this. In other words, things that are far away, more than 3 standard deviations from the mean are really, really unexpected. It's very unlikely that that would happen, okay? And we use this in business scenarios actually fairly regularly. So I mentioned that a normal distribution, or that certain data is normally distributed, like measurements of errors on machines. So when they do like product testing and they're trying to figure out like how much of the product has an error, or then they figure out kind of how many defective parts are, quote, acceptable to them. And then they want to not deviate from this, right? So they can be like, we're 99.7-ish% sure that we'll only have so-and-so number of defective parts. And then if they go outside of that, it would be very unexpected, okay? If they went outside of that, it would probably be an indication that something was really wrong, like maybe a machine was off, or an employee wasn't doing their job, or something like that, okay? So let's kind of break down. Let's look at an example problem, and I want to break down these percentages a little bit further, but I just want you to know I need you to kind of start to kind of commit those to memory a little bit. So let's say that the average on a test is 80. With a standard deviation of 5. Now note, I've already showed you how you would find things like average and standard deviation, right? But standard deviation is kind of a tedious process. So for instance, if you were talking about 20 students, that standard deviation formula would be quite long, right? If you were doing the table version, it'd have 20 rows, right? So it's a little bit tedious. So I'm just going to kind of from here on out tell you what the average and the standard deviation is for us to work with, but just know that that's actually something you know how to figure out if you have to. So let's say the grades are normally distributed, meaning that they follow the bell curve pattern, where we peak in the center, and then the further we get away from the center, the less likely it is. So first, I want you to draw a bell curve. And then I want you to answer the following questions. So before I list for you the questions, let's go ahead and draw the bell curve. So I want you to be pretty detailed with this. So you're going to have kind of a number line down here, and then I want you to draw a bell-shaped curve. So remember that kind of looks like this right here. It should look pretty symmetrical on both sides. It should peak in the center. And what goes in the center is the mean grade. So this is going to be test grades down here. So we always start with what the expected test grade is, which is an 80. Okay, so notice the most people made the 80, right? It peaks in the center. Or most people made around 80, I guess I should say. And then the standard deviation being 5 means that's how far out from the mean you need to go on either side. So I'm going to go out 5 this way and 5 this way because that's the standard deviation. Okay. So notice that's going out 1 standard deviation, right? So let's kind of talk about this kind of as we go. Okay, so what did we say the percentage was for going out 1 standard deviation above? What did we talk about last time? It was 68%, right? So if this is kind of split up into 2 pieces, wouldn't this be 34% and this also be 34%? Okay, for a total of what, of course? 68%. Okay. So then let's go out another standard deviation. So notice this would be at 70 and this would be at 90. So just again to recap, the middle is the mean, right? And then the standard deviation tells you how far out to go each little unit, each little section. Okay. So what do we know about from here to here, where I just drew the lines? What do we know about from grades 70 to 90? How many percentage of the grades should that cover? 95%, right? So let's kind of think outside the box a little bit. How could we figure out what these are? We can't half 95% because we already have 68% covered, right? So how are we going to get those little strips of percentages? Yeah, could we do 95 minus 68? Okay, so that's going to give us 27, but that's 27 total on both sides, right? So then what are we going to do to figure out what each side is then? Divide it by what? 2? Okay, so notice we get 13.5%, so this little strip is 13.5%, and so is this one. Okay, so then we can go out one more standard deviation, because remember, we tend to only go out 3 standard deviations because that should catch almost everyone. So that's going to be 65 and 95. So I'm going to kind of draw more little marks there. Okay, so how am I going to get those percentages? So I still have this one shown, right? Notice out 3 standard deviations is 99.7%. How much percentage do I already have accounted for, though? I already have 95 taken care of, right? Like I already did the 95 in the middle, okay? So I need to do something similar to find these little strips, right? I just need to do what? 99.7 minus what? 95, and I'll get 4.7%, but then again, it's halved on each side, right? So I need to divide it by 2. To figure out what it is on each side. So this is going to be 2.35%. So I'm just going to kind of do this because I don't really think I have enough room to squeeze it in there. But if you do, then you can. Note that if you added all of these up, you would get 99.7, which is what we should have. So then last but not least, let's talk about what these little teeny tiny slivers are that, by the way, are really unexpected to get. But let's talk about what they are or how I could get them at least. Okay, so how would I get those? Using the same kind of logic that I've been doing so far. So how much percentage do I already have kind of taken care of? 99.7, right? And the total percentage can only be how much? 100. So I'm going to do 100 minus the 99.7 that I already know about. And I get 0.3, and then one more time, what do I need to do for each side? Divide by 2. Notice this is 0.15%, so it's actually really, really tiny. And we already kind of talked about that, right? Like it's a small sliver because it's very unexpected. Okay, so notice to get this, so just to kind of point this out so that later on you're not like, where the heck did we get this? To get this, we did 1/2 of 95 minus 68. Okay, that's how we got the 13.5. Okay, to get this, what did we do? We did 1/2 of 99.7 minus 95. And then how did we get this one? We did 1/2 of what? 100 minus 99.7. Okay. Notice that like these percentages will actually hold even when we're talking about a different problem. Does that kind of make sense? Like even if we were doing a problem that didn't have anything to do with test grades, the numbers here would change, but these percentages wouldn't, right? Because the percentages are holding for 1, 2, and 3 standard deviations. Those are kind of solid. Okay, so with that, so we're going to keep that kind of on screen and in mind. I should be able to ask you kind of a series of questions. So what is the probability that a random student scores between 75 and 85. Oh, one more thing. I do want you to kind of mark that this is the mean. Okay, so the middle is the mean, and then we went out 5 every time. Okay, so what do you notice between 75 and 85? So if you just kind of point those out, or you can mark it with your pencil if you want to go ahead and erase that. But notice I'm going from 75 to 85, right? So that is literally within 1 standard deviation. So what do we already know about, even if we didn't have quite as detailed of a picture as we have right there? What would be within 1 standard deviation? What percentage is what I'm asking? What's the probability? About 68%. Okay, I'm going to say about 68% just to let you know that the 68% is actually a rounded version. It's close enough. Okay, but just so you know, all of these 68, 95, and 99.7 are all approximations, but they're as close as we can, not as close as we can get, but as close as we need to get. So let's ask a second question. So what is the range of scores that 99.7% of students fall in? Okay, in other words, what range of scores can you expect for 99.7% of the students? So notice that's not a random percentage, right? The 99.7 is significant. So the 99.7% means what? It means that we're within what? 3 standard deviations. So kind of look at our picture above, right? So if we're within 3 standard deviations, what do you notice the scores are if you go out 3 from the center? So what I mean is 3 sections from the center, right? So 3 to the left would be what score? 65, right? 3 to the right would be what score? 95. So it's basically between those 2 scores. So between 65 and 95. All right, so let me ask you some maybe more challenging questions as we go. I want to kind of keep my graph up there. So part C, what is the probability that a random student scores higher than 95? Okay, so we already kind of have that worked out, right? So what is the probability that we score higher than 95? So I'm going to slide this down a little bit so we can see the graph every time. So what would be that probability? 0.15%, right? So really, really small, okay? So I'm going to write this out, though, just in case. If you didn't have this labeled, you could still figure it out, right? So the probability that x is greater than 95 would be 100 minus 99.7 divided by 2%, okay? Or just what we got above, or 0.15%. So I'm kind of showing the work a second time, right? I already kind of found it up there. So what about this one? What is the portion of students who score less than 80? Oh, I guess I should make that visible. That'd be nice, right? So what is the portion of students who score less than 80? But I'm still going to try to kind of prop this. Okay. What do you notice about 80, though? 80 is square in the middle, right? So if you don't really even need to think about this too hard. It's half one way and it's half the other, right? So it's going to be 50%. So I've got a couple more questions, and then we're going to look at something different, like a different type of problem, but the questions are really going to be the same. So what is the portion of students who score between 75 and 95? So I'm going to slide this down a little bit. So notice I'm not going equal distance on both sides, right? So that's where the little trickiness is, but that's actually where my detail here will actually come into play. So I want to go between this score and this score right here, right? But don't I have all the slivers already figured out? So what could I do with all the little sections between 75 and 95 to figure this out? Yeah, we'll just add them, right? So we've got two 34 sections. We've got a 13 and a half, and we've got a, 2.35? So if you add all of those up, you get 83.85%.
And as far as the last piece, just subtract those last three by 100?
You could, but you'd have to, yes, to answer your question, really there's lots of ways to do this. So you could do 34 plus 50, take away the 0.15. So if that makes more sense to you, sure, you can do it that way. I'm just doing it maybe the most direct way, but yeah, you totally can do it that way. There's lots of ways, so however you want to cover it, if you want to take off the sections that it doesn't include, you could do that too, for sure. So one more question, and then we're going to kind of generalize this for any question, not just, this test question or this test grade question. So what is the probability that a random student scores lower than 90? So notice, that's all of this way, right? So notice it would be quicker if we talked about what wasn't included in this one, right? So it would be faster. Could you add up all those slivers all the way? Sure, okay. Or you can think of it this way, that it's 100% minus only two little slivers, right? If we want 90 and less, we only don't want these two sections, right? So we could just subtract whatever you get when you add those up. Or you could, again, go straight for it and just add up, 1, 2, 3, 4, 5, 6 sections. But I think this is quicker to do 100 minus the two we don't want. All right, so without trying to kind of make you keep drawing these, the more you draw them, the more they'll kind of implant in your brain. But I'm going to leave kind of that up. This is the general format for a normal distribution. So we're going to draw it one more time, just kind of generally, because that time we just did it for specifically that problem. So in general, we're going to be 0 standard deviations, in other words, at the mean itself. And remember, we're only going to go out 3 standard deviations on either side. So this is 1 standard deviation, 2, 3, -1, -2, -3. So I'm just going to kind of do this rather quickly. For these two middle strips, it's 34%. For these two strips, it's 13.5%. Rather than you memorizing all of these strips, though, I'd rather you understand how it is that we got them. Okay, so if you know the 68, 95, 99.7, you actually should be able to create this for yourself without just having to memorize it. I'd always rather you understand something than just, memorize it without really knowing what you're doing. So this is 2.35%, trying to squeeze it in. And then the outside sections are 0.15%. So just know that if you ever take a business statistics class, which is part of some of your degree majors or degree plans, some of you won't have to take it, but you'll go a lot more into this. What we're going to stick with is things that are exactly 1, 2, or 3 standard deviations away. But just know that you can be somewhere in the middle too. Like what if someone scored on our last problem like an 82, right? That wouldn't have been within 5, right? But it's possible to score an 82, so it would be like a partial standard deviation away. So anyway, just know that you might go a little bit further with this if you take another class that involves stats. So all we're really trying to do here is give you a introduction to normal distribution, definitely not go all the way into it. Okay, so let's do another problem. So let's say that 95% of women have shoe sizes between 5 and 9. So I want you to find the mean and the standard deviation if the data is normally distributed. Okay, so the fact that they're telling you, or that I'm telling you that it's normally distributed means that it's going to follow that bell curve pattern. Okay, it's going to peak in the center, it's going to go off from there. But there is a significance about 95%, right? There's a reason why I gave you 95% and not something else, right? That's one of our 3 significant percentages that I mentioned, right? So how many standard deviations is 95%? It's within 2, right? So within 2 standard deviations, we're supposed to be between sizes 5 and 9. So let's go ahead and draw a basic curve here, right? So notice, this is where the mean is going to go, but I actually don't know what that is right now, right? So I'm going to go and draw my bell curve. So that's actually one of the things I'm trying to find is what the mean is, right? But what do I know? I know that when I go out 2 standard deviations on either side, right, that I end up at sizes 5 and 9. So that much I do know, right? So then we just want to try to fill in what this would have to be. So what do you know about the mean? Since we're at 5 and 9, the mean's going to have to be what compared to those 2? Right in between them, right? Because we went out 2 standard deviations to the left and got 5, and we went out 2 standard deviations to the right and got 9. So what's going to have to be right in the middle? What's the only number that makes sense? 7's going to have to be in the middle, right? Because it's 2 on one side then, that way, okay? And then what would the 1 standard deviation have to be? Because remember, we have to be evenly spaced out everywhere, right? So what are these 2 things going to be? This is going to be 6 and this is going to be 8, okay? So that means the mean was 7. And what was the standard deviation? Remember, standard deviation describes like how far out you're going each time. So how far out are we going for each little tick mark? 1 unit, right? So the standard deviation is 1. Okay. So the mean always has to be, right in the middle if you draw it out like that. Okay, so let's do some questions about this now. So, if I ask you, what is the probability that a random woman has a shoe size less than 5. So you can go and do the strips again for every problem, but it's kind of tedious to do all that, right? That's a lot of things to write down, a lot of percentages. So I want to see if we can do it another way, kind of logically instead. So let's talk about this. So we know that we have 95% of the values covered here, right? We were given that, right? We know that between 5 and 9 or 95%. So what I'm asking you about, and I'm going to use pencil so that I can erase it, I'm asking you about what this little sliver must be over here, okay? So how would I get it using the same logic that I got my percentages before? If I know the middle is 95, then what do I know about outside the middle? It's how much percent? Like what's 100 take away 95? It's 5, right? And then we got to split it on both sides, so it would be literally just do 100 minus 95 divided by 2, and we would get 2.5%. Okay, so let me slide this back up. By the way, that is exactly what you would have gotten if you would have added these two slivers together. 2.35 plus 0.15 is 2.5. But I don't really know that we need all that detail to be able to do most problems. Okay, so what if I ask you this? What is the probability that a random woman has a shoe size larger than 6? So again, we're going to try to do it without the little strips of percentages, just in case you don't want to do that or you don't have time. Okay. So I'm going to take my pencil and I'm going to erase so that I can kind of remark what I'm doing here. So now I want to go 6 and bigger, right? So I want to do kind of all of this. I'm going to really lightly shade it. Okay. So in fact, you can't even see that I shaded it. You sort of maybe can, not really though. I don't really want to do it super, super dark because I'm going to erase it anyway. But let's do it a little darker. So maybe it'll show up with this janky lighting in here. No, not so much. Okay. So right here, I'm just going to do this. It's this way, right? Everything that way. Apparently pencil just doesn't show up at all. Okay, it's everything from 6 bigger, right? So I think we could do 7 bigger really easily, right? 7 or bigger is how much percent? 50%, right? Because it's 50% on one side, 50% on the other side, okay? But then I think we could get between 6 and 7 relatively easily, right? So there's all kinds of ways to do this, but one way to do it would be like 50% for 7 or more than 7. And then plus, how could I get that sliver just like and write it down without having to go back up and look at the percentages? So we know from 6 to 8 would be 68%, but I only want from 6 to 7, so it would be half of that, right? So it would be 50% plus 68% divided by 2, okay? Because this covers between 6 and 7. Okay, so that might not be the way you do it, but in the end you get 50% plus 34%, which is a total of how much? 84%. Okay. So even with a somewhat non-detailed normal distribution, if you know your 3 percentages, you should be able to get a lot of the combinations of things you might see on the homework. Okay, so I'm going to erase this just because in the future I don't want it on there. So honestly, that's how I do. I'm kind of a more visual learner, so that's really like with a pen. I usually draw my general normal distribution like this, and then as I am asked different questions about it, I might make a mark with my pencil and shade it in, and then I can erase it for the next part. Okay, so that might be something you could try. Okay, So let's do one more where we kind of have to use a normal distribution. But I am going to give you some of the info because otherwise it's really tedious. So the following is a list of grades out of 60 points. Oh, I can't spell of. So let's say I was recording the grades and these are the grades. So remember it's out of 60. So some of these grades aren't fabulous, but they're better than they'd be if they were out of 100, right? So these might be like the grades that my calculus teacher that I mentioned last time gave, right? Where the average was like a 30-something. The test, basically the teacher decides that the test was too hard. And so decides to only fail students one standard deviation from the mean away. And so my question is, who will fail with this grading system? By the way, even out of 60, everybody failed, right? So that's why the teachers made this determination that, hey, like nobody passed this test, so I'm gonna curve it, but I'm not gonna curve it just with points. I'm gonna curve it as a normal distribution. All right, so I'm gonna just give you these numbers because I think we can agree that like this would be a long formula to kind of come up with. So the mean is going to be the sum divided by 11. So I'm just going to tell you that that's 23. And then I'm also going to give you the standard deviation. Remember, S is what stands for the standard deviation. And let's say that I get the standard deviation to be about 6.6. So remember, we have a formula for that. You can either do the chart or you can do the square root of all the differences between the values minus the average squared, add them all up, and then divide by n minus 1. So let's say that you get 6.6 there, okay? So let's come up with a normal distribution curve for this. So we've got a bell curve. And we've got 23 in the middle because the mean always goes in the middle. But then the standard deviation tells you how far out to go on each side, basically. So if we go out one standard deviation, which if you look at the problem, that's actually all we have to go out because it only mentions going out one standard deviation. So how are we going to get the numbers that go on either side of 23?
Do you add 6.6?
Yeah, add 6.6 for the right, and you're going to do what for the left? Subtract 6.6, right? So 29.6 goes here. And 16.4 goes here. If you were to subtract 6.6 from 23, you'd get 16.4. Okay. So what that means is what he's decided to do is he's decided to pass all of these students that were above that line of 16.4, right? And he's going to fail all of these students. Okay. So in other words, which scores above are going to fail? Which scores are below the 16.4 level of passing that the teacher came up with? 15 is a failure, and the 14 is a failure, right? So basically, only 2 students will fail after this bell curve. So only 2 students fail after the curve. So if you ever have a teacher who curves on a bell curve, this is what they mean by that. Instead of just adding, 10 points to everyone's test or something like that, like a normal curve is, that's a point curve. A bell curve is how far away from the expected middle are you, basically, okay? So the reason it's not fair, in other words, the reason I don't think it's fair to grade on a bell curve is because you're being compared to everyone else in the class, okay? So what if you have a particularly high level class that you're in, right? So what that means is if you were in a class of people that did really poorly, you might do really well compared to the average, right? But if you were in a class of people that did really well, then you may not have as high of a score. Does that kind of make sense? So the reason I don't ever use a bell curve is because you should be evaluated on your own merits, not on how your own merits compare to the other people in your class, right? So I don't think it's a very valid way to grade, but that does not mean that there aren't teachers out there that do it. So just FYI.
So
Yes?
when people say I set the curve, is that talking about a bell curve?
That can be either form of the curve. Like if someone says I set the curve, they could just mean they had the highest score. So how a points curve works is if the highest score is a 90, then traditionally that 90 is supposed to bump up to 100, and so it bumps everybody up 10 points. How this works is you just decide on how far down you're willing to go as far as pass-fail goes, and then you kind of adjust it from there. So the calculus teacher that I mentioned, he set the middle, and then he figured out the standard deviation. And so if you were in the higher level of the curve, so if you were over here, you got an A. If you were about here, you got a B. If you were in the middle, you got a C. Does that make sense? So he split it up like that based on our specific test scores. But again, that was a little janky, right? Because we were being compared to the other people in the class. So grading on a normal curve is not something you'll see very much anymore, but all sorts of things in real life actually follow a normal distribution. So we talked about those last time. Remember, any measurement of data usually follows a normal curve, where there's some average, and then the further you deviate from that average, the less likely it is. Okay. All right, so that's pretty much all I've got for today. So starting next week, we're going to be looking at some graphing questions. So if you have graph paper, you can bring it next week. But I'm also going to provide you some if you don't have any. So I have some graph paper that are like little grids. But if you want to use your own, you can, but don't feel like you need to go and buy any. So.